So this exercise is related to topic alkanes and alkenes. And we'll start with question 31 because already some of the questions are recorded. So I will start with question 31 and I'll solve. It has both MCQs and the structure question. So this is the question 31. Which of the following does not represent the structure of a compound 2-methyl pentene? So first what we have to do, we can name each of them and we select the longest the rule is that first thing you always try to select the longest carbon chain. That is first thing. And the numbering should always start with the nearest functional group or a branch. So if you check the first structure, what is the name of the first structure? We select the longest carbon chain. So if I select like 1, 2, if I select this 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's 5 are there. Or if I select 1, 2, 3, 4, 5, that is one possibility. So maximum I can get 5. So maximum I will have 5. Any way I select, it will not make difference. Even I select this one, this is also giving us 5. So we select the longest carbon chain. Then after selecting a longest carbon chain, the numbering should start from a nearest double bond. So if I count from here, 1, 2, 3, the third carbon is having a double bond. If I count from here, 1, 2, 3, 4, 5, because we give a priority to the double bond. Why we cannot select all of them? Because then the rule is that when you start with one end, you should end at other. This molecule is having 3 different ends. This molecule is having 3 different ends. This is one, this is another, and this is another. CH3 is always at the end of a molecule. CH3 cannot be in between. So how many CH3 do you see here? 3 CH3s are there, so it means it has 3 ends. So how many CH3 you see, that will give us the number of the ends. So 3 CH3 groups are there, so 3 ends are possible. So when we start from one of the CH3, we should end at another CH3. So maximum, like example, if I select here, before I selected up, but now if I select here, so I will also have 5. If I count from here, 1, 2, 3. If I count from here, 1, 2. So second position, I have a double bond and the branch, so I'll give a priority to the second position. Like counting from here. 1, 2, 3, 4, 5. So second position, we have a methyl group. So I'll say this is 2-methyl. Then 1, 2, 3, 4, 5 carbon atoms are there. One, two, three, four, 5 carbon atoms are there. So it is 2-methyl. 5 carbon atoms, what I will say? I will say pent because of the 5 carbon atoms. So pent is there. Then the second carbon is having a like the double bond with the second carbon. So pent. Second carbon is having a double bond 2 and ene. So this is actually 2-methyl pentene. So this is, we want which does not represent. So this is 2-methyl. So this is not an answer. Let's check the second option. Again, we select the longest carbon chain. So again, 3 ends are there. If I select, and we have to include a double bond because double bond is a functional group. So 1, 2, 3, 4. No. If I count from here, 1, 2, 3, 4, 5. So this is a branch. What is not selected is considered as a branch. Now I will count from here. If I count from here, because the double bond is a priority group for us. So if I count from here, one, two, three, third position, I will have a branch and a double bond. But if I count from here, one, two, three, second position, because the double bond is a priority group, like it is affecting the chemical properties. So one, two, three, four, five. So third position, we have a branch. So it is 3-methyl. 5 carbon atoms are there. It is pent. Second carbon is having a double bond, so it is 2-ene. So it is 3-methyl pentoene. That's why B will be the right answer. Like, because B is not representing the structure of 2-methyl pentoene. What about option C? Like if we choose C, why C is also 2-methyl pentoene. We select the longest carbon chain because 3 ends are there. So either you can select from this one or you can select the other top. Because if you start with one CH3, you should end at CH3 as well. When you count 1, 2, 3, 4, 5, so second position, there's a methyl group. So it is 2-methyl and 5 carbon atoms are there pent. And second position, second carbon, there's a double bond. So it is pentoene. When I'm saying there are 3 ends, because as you can see, this is CH3, this is CH3, this is CH3. So when we select the longest chain, we can include only 2 ends in the longest chain. So if I start from here, that one possibility, I select this as my longest chain. Or if I start from here, that another possibility, I select this as my longest chain. So this CH3 will be out. That will be the branch. And what about option D? As you can see, how many ends do we see? This is CH3, 1 end, 2 end, and 3. But we select the longest chain from one end to another. So if I select this as my longest chain, 1, 2, 3, 4, 5. Or I can select this as my longest chain, 1, 2, 3, 4, 5. Or I can select this as my longest chain. This I cannot select as a longest chain. Why? Because it's a shortest chain plus the double bond is not included. I have to include a double bond which will affect the chemical properties of this compound. So when we count from here, it is 1, 2, 3, 4, 5. So second position, there's a methyl group. So it is 2-methyl. Second position, there's a methyl group. So 2-methyl. 1, 2, 3, 4, 5. So it will be pent and the double bond with the second carbon. So it is 2-ene. So 2-methyl pentoene will be the right structure. So all of them are, except B, all of them are 2-methyl pentoene. The next is, the question is actually related to the fraction distillation of a crude oil. Crude oil is a source of alkanes. As we do fraction distillation, we separate these alkanes on the basis of their boiling point. So name the process by which hydrocarbons in a crude oil are separated. So what we call that process, we call that as a fractional distillation. So fractional distillation is actually a technique which is used to separate two or more miscible liquids or gases on the basis of the boiling point. Alkane X is composed of a straight chain molecule with a 9 carbon. Give the molecular formula. They mention it's a straight chain and it's an alkane. So what is the journal formula of alkane? The journal formula of alkane is CnH2n plus 2. So if we have 9 carbon atoms, how many hydrogen will be there? So it will be 9 multiplied by 2 makes 18 and 18 plus 2 makes 20. So it will be C9NH20 will be the molecular formula of this X. Y is a branch isomer. It has 8 carbon in a straight chain and 1 methyl group on the side. Draw the skeletal formula of one possible structure. So Y is a branch. We have to draw the skeletal formula first. If we, anywhere we can place a branch, but branch can only be, the carbon branch can only be placed from second to the second last carbon. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8 carbons are there. And I can put a branch here, even the second, or I can put a branch here. You can, because it's multiple possibilities are there. So what is the name of this compound? If I number, I have to number as well. If I number from the right hand side, this will be the first, second, third, fourth, fifth, and sixth carbon. But I have to number from, so sixth carbon is having a branch. But if I number from here, 1, 2, 3, 4, 5, 6, 7, and 8. So third carbon is having a branch. I do a branch with the third carbon. So what is the name of this compound? It will be 3-methyl, and 4 carbon atoms, 8 carbon atoms are there, oct, and they have a single bond in. So it is 3-methyl octane. Is it clear, this one? You can place anywhere because they mentioned one possible structure. So there are multiple possibilities in this case. You can attach with a fourth, you can attach with a second, so it will be 2-methyl. Then we have a reaction which is called a cracking. In a cracking, what we do, we break down the long chain compound into a small useful one. So C15H32 is heated in the presence of a catalyst. Give an equation to show the cracking of one molecule of C15H32 to form one molecule of ethene and a molecule of other product. State symbols are not required. So if you are cracking and one molecule of ethene is produced, so we are cracking C15 and H32. One molecule of ethene is there. Eth means 2 carbon and ene is there, so double hydrogen. So how many carbon are left? Another one product is there. So out of 15, if 2 are used here, how many are left? 13. And if out of 32, if 4 are used here, so how many are left? So 28. So C13 and H28 will be the other product. Because the total number of the carbon on the left hand side must be equal to total number of carbon on the right hand side. What if they said 2 molecules of ethene are produced? Like the same question, they said 2 molecules of ethene are produced. Then what will be the product in that case? Because out of 15, if I use 4 here, so I'm left with 11. So I will write C11. And out of 32, if I use 8 here, so I'm left with 24. So C11, H24 will be there. So it depends on the question. They already mentioned it's only one molecule of ethene. So we just use one and then remaining will be the other product. In practice, cracking of a pentadecane from large number of products suggests why this is so. What is the reason why multiple? Because the carbon-carbon bond, any carbon-carbon bond can break in this long chain compound. That's why multiple, it's a very long chain compound, like 15 carbon atoms in the structure. So the carbon chain is so long that the bond can break, any of the bond can break. As a result, multiple products are possible. Even the equation which we wrote, that product, this product might further decompose. So the answer is suggest what is the reason why large number of products are possible. You will mention because in a it's a very long chain compound which contain many carbon-carbon bonds. So any of the carbon-carbon bond can break, which result in a multiple products. In a petroleum industry, some straight chain alkane are processed to form cyclic. What we call this process, we called a reforming, in which we convert the straight chain into branch or a cyclic. So when octane is processed, each molecule of octane produce one molecule of a cyclic hydrocarbon, C8 and H12, and three molecules of a hydrogen as only product. Complete the skeletal formula of one of the possible cyclic hydrocarbon. So 1, 2, 3, 4, 5, 6, 7, and 8. So we have to complete the skeletal formula for the possible, as I mentioned here, when octane is processed, one octane produce one molecule of a cyclic hydrocarbon, and it is producing three molecules of the product, three molecules of hydrogen as well. So what is this? What is the molecular formula of this compound? If you see 1, 2, 3, 4, 5, 6, 7, 8. So this is C8. And how many hydrogens are there? This will be CH3, so 3 hydrogen. Because how many bonds? So this will have 3 hydrogen. This will have 1 hydrogen. This will have 2 hydrogens. This will have 2 hydrogen, 2 hydrogens, 2 hydrogen, 1 hydrogen, and 3 hydrogen. So total, how many hydrogens are there? So total are 12. Because like 4, 8, no, not 12. We want a hydrocarbon to have 12. But what about this one? If it, according to a given structure, how many are there? 3 plus 1, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it has 16. This is a skeletal formula which is also cyclic, but this skeletal formula has a molecular formula of C8H16. We want to convert this structure into C8 and H12. So how we can convert this structure? Actually, what we have to do, we have to make a double bond within this skeletal formula. How many doubles bond I have to do? Like example, right now it has a formula of C8 and H16. That's a formula. If I place a double bond here, if I place a double bond, how many hydrogen are left? This is 3, 1, 1, 1, 2. Now they have only one hydrogen left, 2. So 6, 8, 10, 12, 14. Still I did not complete. We want to complete to C8 and H12. So where another double bond I can place? If I place a double bond here, anywhere you can place, as multiple possibilities are there. So this will have 1, this will have 0, because so 3, 4, 6, 7, 8, 9, 10, 11, 12. So C8 and H12. Now this is the right skeletal formula according to C8, H12. Before, when all were single bonds, it was actually C8 and H16. So we have to add the double bond within the structure so that it will become C8 and H12. Is it clear? So even I can place a double bond at this one as well. Now this will be 2. This will not have any. I, I can place here as well, or 2. This will not have 2, 2, 4, 6, 8, 10, and 12. So this is also another possibility. Like this is also a right formula because we want a molecular formula to be C8 and H12. In the middle line, if you want to put 1, 2, 3, if you put here, that's also fine. But the maximum carbon should be 4 bonds. If you put one here, you put one here, that's also fine. Only the structure we have to add 2 double bonds. Suggests why petroleum industry processes straight chain alkane to form a cyclic. So why they form a cyclic compounds? Why straight chains are converted into cyclic or the branch? Because the cyclic compound will be volatile, so it can burn easily. So for efficient combustion, mainly it is used for efficient combustion or smooth burning. That's why straight chain are converted into cyclic. So cyclic compounds can burn more easily as compared to straight chain. Burn less is not it's to write a more structured answer. Best thing is you can say it will promote like more efficient combustion is there. It reduce the knocking as well, like the sound during a combustion, that also it reduce. Or smooth burning, you can also say, or burn easily. Or you can also say straight chains are less difficult to burn, that you can mention. So this was question 32 from exercise alkanes and alkenes.